Let us start now. Wait a second. Okay. So we have 4 quadrants. We have 2 planes actually, vertical plane and horizontal plane. Those are mutually perpendicular planes, and the intersecting line between vertical and horizontal plane is called ground line or reference line. So both the 4-angle projection methods are possible, but second angle and fourth angle projection method drawing is not drawn because of the overlapping views. So for second angle projection method, overlapping views will be obtained above the GL line, and for fourth angle projection method, overlapping views are obtained below to the GL line. But for first angle projection method, you have front view or front elevation actually it is called, and plan or top view. So at above to the GL line you will have front elevation or front view, and below to the GL line you will have plan or top view. And for third angle projection method, you have front view below to the GL line and top view above to the GL line. Okay, so plan and elevation, these terms are for the first angle projection method, but casually a front view and top view views are being set, but actual thing is plan and elevation for first angle projection method. But for third angle projection method, front view and top view. Okay, so here a figure is done, just follow my cursor. So the object is placed in the first quadrant. The simple object is placed in the first quadrant. So observer will be here. So the light rays, they are actually light rays, and in technical terms they are called projection lines. They are parallel to each other and perpendicular to the plane of projection. So this is the vertical plane of projection, and this is the horizontal plane of projection. So for front view, observer is here, and for top view, observer is looking from here, from top. Okay. So 2 mutually perpendicular views are possible, but in our drawing sheet, it is not possible to be drawn to mutually perpendicular plane, as is a flat sheet. So we have to merge the horizontal plane with the vertical plane by rotating the horizontal plane clockwise 90 degree. Okay. So then top view and front elevation or front view and plan or top view. Okay, now just see here, this is a first term cone. I have already told you during the conic section that when the cone is cut parallel to by a plane parallel to the base, a circle is obtained. So that is the first term cone. So 2 circles, one smaller and one bigger circles are there. So let us say that cone is placed in the first quadrant, and you will have another auxiliary plane which is perpendicular to both VP and HP. Okay, so 3 mutually perpendicular planes we have. So now we have another plane. This is the auxiliary plane to obtain the side view. Okay, side elevation. Okay, so now the position of the observer is here for the front view, and for the side view now position of the observer will be here. Okay, for top view he or she will be here, and for the side view he or she will be here. Okay, so the shadow is 2 circles, and here shadow is trapezium shape, isn't it? Now again these 2 mutually perpendicular plane cannot be drawn in our flat sheet. So that plane has to be merged with the vertical plane. So if we rotate that auxiliary plane again 90 degree clockwise in that direction, just follow my cursor. It will be merged with the vertical plane. Then 2 views will be obtained like that, isn't it? So this is the symbol. Please note it down. This is the symbol for first angle projection method. Okay. So that's how the first angle projection symbol comes. Now we'll move to the line projection. Line is nothing but, line is the minimum distance between 2 points. So here it is the first quadrant. Now we'll always consider the first quadrant only, not the third quadrant. Okay. So here 3 conditions are given of the same line of same length. Okay. So firstly we are considering that EF. Okay, see, it is parallel to both vertical and horizontal plane, isn't it? So where we are telling parallel, because distance of all the points on EF line is equal from the vertical plane. That's why you can say it is parallel to the vertical plane. And it is also the distances of all the points on the line is equal, are equal from the horizontal plane. So it is then again parallel to both vertical and horizontal plane. Now, so to draw the projection, it will be like that. So the true length of the line, that is, let us say 50. So the true length of the line will be seen on both the vertical plane and also on the horizontal plane also. Okay, so the top view is designated by small letters, small alphabets, EF, as it is capital EF, so small EF, and front view has been designated by dash, only EF and EF, E dash, F dash. So you will know that E dash means it is the front view of E, and F dash means front view of F. Okay, so see, so this distance, that is the distance of E from the XY line, is this one. There is the distance of E from the vertical plane, isn't it? So this distance is this, and small e to E is the distance of E, capital E, from the horizontal plane. So this distance is here, isn't it? So they are drawn like that. So both the lengths are equal, if that as the true length. But at the second case, now you see 3D line is parallel to the vertical plane. Why you are saying it is parallel? Because again you see that distances of all the points on the line are equal from the vertical plane. So it is said to be parallel to the vertical plane, isn't it? But it is not parallel to the horizontal plane, because distance of C is different, distance of D is different. So distances of all the points are different. Okay, so we can say that 3D line is not parallel to the horizontal plane. Okay, so that length, small CD, or the top view of that line is not 50. Okay, so it is reduced somewhat. So but the front view of CD line is the true length, because it is parallel. So on the vertical plane, true length of the line will be obtained. So how the drawings are drawn? Actually, first reference line is drawn, and the distances. So the C point will be some distance above than that of the from the horizontal plane, and the inclination of line will be something. So the distance is taken, and then the inclination is drawn. So then the D point will be found, and two projection lines are drawn. These are the projection lines, as I was telling you. These are two projection lines, and so C is some distance in front of the vertical plane. So that distance will be here. We have to take the distance and have to cut the line, and only the two views of the line will be dark, otherwise the projection lines will be thin. Now the third case. Now it is C. It is parallel to the horizontal plane, because the distances of all the points from the plane are equal, but it is not parallel to the vertical plane. So the true length of the line can be seen in the horizontal plane here. This is horizontal plane, this is vertical plane, but true length of the line cannot be seen at the vertical plane. So AB is the true length, and A dash B dash will be the reduced length. And how much reduction has been made, that has to be decided after the drawing. That cannot be said. Only true length we can know, but the reduction of length we cannot tell arbitrarily. That has to be drawn. So that distance of A point will be a particular from the vertical plane. So that distance is drawn here. Then the inclination will be drawn. So then AB length will be found. Then we have to draw two projection lines, and then the line will be some above than that of the from the horizontal plane. So that distance is here. So this is the basic concept. of the line. So line can be inclined, line can be parallel to both the planes, line can be parallel to one plane and inclined to another plane, and the third condition is a line can be inclined to both the planes. So we will do problems by all the three conditions. So here the first problem, a line PQ 90 mm long, so true length is given, is in the HP, okay, and makes an angle 30 degree with the VP. Its end P is 25 mm in front of VP. Draw its projection. Now we have to understand the line is parallel to which plane and inclined to which plane. Then we have to decide the true length of the line can be obtained in which view, and the drawing has to be started from that view only. Okay, so we have to understand by the statement of the problem that in which plane the true length of the line can be obtained. So line PQ 90 mm long is in the HP. That means that will be on the HP. So here the line is, okay, here the line is on the HP, and makes an angle 30 degree with the VP. So that angle is 30 degree, and the third condition, and P is 20 mm in front of VP. So that end is 20 mm in front of VP. So it is that can easily be understood that as it is on the HP, so the true length is obtained on the HP only. So at the top view, here the true length of the line will be obtained. So we need to draw XY line first, okay. Then as is said that P is 20 mm in front of VP, then we have to take the P point 20 mm, 25 mm away from the XY line. Okay, so P point is taken and the inclination is given 30 degree. So 30 degree line is drawn and of 90 mm length. So PQ length is 90 degree at an angle of 30 degree. Okay, so once the line is drawn, two projection lines are to be drawn, and that portion will be made dark as it is on the HP. So for that case, it is not on the HP, it is some above the HP. So that distance was taken, but it was said it is on the HP, so line will be drawn here. And that's why line is drawn on the XY line. So again, as I told you that front view is designated by dash and top view by only the small letter of the alphabet. Okay, so this is one condition. Next condition is this, that is like that. Okay, there is parallel to VP and inclined with HP. Okay, so parallel to VP and inclined with HP, like the second condition here. Now the length of the top view is given. Okay, the length of the top view of a line parallel to the VP and inclined at 45 degree to the HP, okay, is 50 mm. So the length of the top view is given now, not the length of the line is given. We have to start drawing from the top view because we know the length, isn't it? One end of the line is 12 mm above the HP, okay. So firstly we need to draw the XY line obviously. Then as it is said that one end of the line is 12 mm above, so we need to take a point, let us say A dash, from the XY line and 25 mm in front of VP. That means that A dash has been found 12 mm above. So A will be found 25 mm below, isn't it? So from the XY line, along that line only, okay, so projection line is like that A and A will be on the same vertical line. Firstly, you take a point to 12 mm above, and from that point draw a vertical line, and below the XY line take a point A. So these two distances, so A dash and A has been found. Now see, now it is given that the length of the top view of a line parallel to the VP inclined to 45 degree. This will be done later on. Is 50 mm. So we need to draw a horizontal line of 50 mm length. Okay, so hence the B point is found. Now A dash has already been obtained. Now you have to draw a vertical line from the B, up to which I don't know. Okay, up to which point I don't know. Now another condition given, that 45 degree to the HP, the inclination. So just starting from A, draw a line at 45 degree inclination. Okay, so we have the vertical line already, and if we draw a line from A dash at 45 degree, so those two lines will intersect at some point. So that intersecting point is B dash. Okay, so just make A dash, B dash, and AB dark. So these will be two views. Okay, I repeat again. Take 2 points A dash, 12 mm above from XY and 25 mm below from XY, and draw the horizontal line of 50 mm length. So B point is obtained. Now from B, draw a vertical line, length is unknown still, and from A dash, draw a 45 degree inclined line, still the length is unknown. So that inclined line and that vertical line will intersect at some point. So that point will be that B dash point. So that's how it is drawn. Now the third condition is that the line is inclined to both the planes. Okay, this is that the line is inclined to both the planes. So a line AB, so it is length is given as 65 mm, has its end A 25 mm above HP. So again, draw the XY line and take a point 20 mm above HP. So A dash will be 25 mm above HP. So and draw a vertical line from A dash. Okay, and 25 mm in front of VP. So that A dash will be found from 25 mm below the HP. So both A dash and A points are found. The end B is 40 mm above the HP. So end B is 40 mm above the HP. So from XY line, just draw a line, this line, okay, 40 mm above the HP. Okay, so we have to draw a horizontal line only. Above the B, above the XY line, we need to draw a horizontal line only. Okay, so two lines are so A dash point is obtained and that line is obtained. Now in your pencil compass, if you take 65 mm length and make center at here, and if you cut a point on that horizontal line, then that point will be obtained, A dash B dash, isn't it? So B dash, A dash B dash is 65 length. I repeat again. So we have found the A dash point, isn't it? Now the next condition, the end B is 40 mm above the HP. Okay, so we need to draw a horizontal line 40 mm from the XY line. Okay, that line EF line is 40 mm above the XY line, and then in pencil compass you have to take the length 65 and making center at A dash, just cut a point on the horizontal line, isn't it? So that then you will find B dash. So A dash B dash of 65 length is found. Next, the next condition, and 65 mm in front of VP. That means we have to draw a line 65 mm from the XY line. So JK is 65 mm away, as is mentioned already here. Is it mentioned already? So 65 mm away from the XY line, another line is drawn. Again, we have to take the 65 mm length, and that length has to be cut here. So the B1 is the 65 mm length. Okay, so AB1, that point is found. Okay, AB1 is the 65 mm length here. Now what we have to do, these two are drawn now. So B dash is obtained. From B dash line, we need to draw a vertical line up to that line, 25 mm line. Okay, so through A line, a horizontal line was drawn, and through A dash line, a horizontal line was drawn. So to form B dash, so we have found up to this point we have found A dash B dash and A B1, isn't it? So two lines are found, A dash B dash and AB. So from that B dash line, drop a perpendicular line up to that, up to the horizontal line drawn from A, and from B1 line, just draw a vertical line up to the point, uh, up to the line AD. Okay, so up to this point we have drawn this line, and this is marked already, B dash B, and this line B1 from B1 dash. Okay, now what we have to do now, we have to take the pencil compass again and take the radius A dash B1, and that radius is cut like that, B2 dash. Okay, so taking radius A dash B1 dash, we need to draw an arc up to the EF line, so that intersecting point will be B2 dash, and making center at A up to that line AB, we have to take the radius and have to draw an arc up to that horizontal line JK, so that point will be B2. Now if you join A dash B2 dash and A B2, then these two are this line A dash B2 dash and A B2, these two lines are the final view of the line. Okay, so draw the projection, the projections are drawn, and so is in inclination. So now you have to what you have to do, only you have to measure the angle. Okay, measure this angle, means up to from the horizontal line up to A dash B2 dash, that angle, and from the horizontal line up to that A B2, so that angle. Those two angles, after marking those two angles, so these have been you have to obtain. So that's how this problem is drawn.